Shifting cultivation is an agricultural system in which plots of land are cultivated temporarily, then abandoned and allowed to revert to their natural vegetation while the cultivator moves on to another plot. The period of cultivation is usually terminated when the soil shows signs of exhaustion or, more commonly, when the field is overrun by weeds. The length of time that a field is cultivated is usually shorter than the period over which the land is allowed to regenerate by lying fallow. This technique is often used in LEDCs or LICs. Of these cultivators, many use a practice of slash and burn as one element of their farming cycle. Others employ land clearing without any burning, and some cultivators are purely migratory and do not use any cyclical method on a given plot. Sometimes no slashing at all is needed where regrowth is purely of grasses, an outcome not uncommon when soils are near exhaustion and need to lie fallow. Advantages of slash and burn method. Slash and burn is a very sustainable technique. It differs a lot from commercial farming, because once the trees are burned, there is very fertile fine ash that deposits along the humus, meaning that by the time the other fields are burned, the soil has time to reassemble nutriments, in order to make cultural activity possible. Although slash and burn is a very useful technique, there are other ways of fertilizing soil. By planting beans, the soil will regenerate much faster, due to the production of nitrogen in their roots. Political ecology of shifting cultivation. Shifting cultivation is a form of agriculture or a cultivation system, in which, at any particular point in time, a minority of fields are in cultivation and a majority are in various stages of natural regrowth. Over time, fields are cultivated for a relatively short time, and allowed to recover, or are fallowed, for a relatively long time. Eventually a previously cultivated field will be cleared of the natural vegetation and planted and crops again. Fields in established and stable shifting cultivation systems are cultivated and fallowed cyclically. This type of farming is called jumming in India. Fallow fields are not unproductive. During the fallow period, shifting cultivators use the successive vegetation species widely for timber for fencing and construction, firewood, thatching, ropes, clothing, tools, carrying devices and medicines. It is common for fruit and nut trees to be planted in fallow fields to the extent that parts of some fallows are in fact orchards. Soil-enhancing shrub or tree species may be planted or protected from slashing or burning in fallows. Many of these species have been shown to fix nitrogen. Fallows commonly contain plants that attract birds and animals and are important for hunting. But perhaps most importantly, tree fallows protect soil against physical erosion and draw nutrients to the surface from deep in the soil profile. The relationship between the time the land is cultivated and the time it is fallowed are critical to the stability of shifting cultivation systems. These parameters determine whether or not the shifting cultivation system as a whole suffers a net loss of nutrients over time. A system in which there is a net loss of nutrients with each cycle will eventually lead to a degradation of resources unless actions are taken to arrest the losses. In some cases soil can be irreversibly exhausted in less than a decade. The longer a field is cropped, the greater the loss of soil organic matter, cation exchange capacity and in nitrogen and phosphorus, the greater the increase in acidity, the more likely soil porosity and infiltration capacity is reduced and the greater the loss of seeds of naturally occurring plant species from soil seed banks. In a stable shifting cultivation system, the fallow is long enough for the natural vegetation to recover to the state that it was in before it was cleared, and for the soil to recover to the condition it was in before cropping began. During fallow periods soil temperatures are lower, wind and water erosion is much reduced, nutrient cycling becomes closed again, nutrients are extracted from the subsoil, soil fauna decreases, acidity is reduced, soil structure, texture and moisture characteristics improve and seed banks are replenished. The secondary forests created by shifting cultivation are commonly richer in plant and animal resources useful to humans than primary forests, even though they are much less biodiverse. Shifting cultivators view the forest as an agricultural landscape of fields at various stages in a regular cycle. People unused to living in forests cannot see the fields for the trees. rather they perceive an apparently chaotic landscape in which trees are cut and burned randomly, and so they characterize shifting cultivation as ephemeral or a Euro pre-agricultural, a Euro unregistered trademark, as a Euro primitive, a Euro unregistered trademark, and as a stage to be progressed beyond. Shifting agriculture is none of these things. Stable shifting cultivation systems are highly variable, closely adapted to microenvironments, and are carefully managed by farmers during both the cropping and fallow stages. Shifting cultivators may possess a highly developed knowledge and understanding of their local environments and of the crops and native plant species they exploit. Complex and highly adaptive land tenure systems sometimes exist under shifting cultivation. Introduced crops for food and as cash have been skillfully integrated into some shifting cultivation systems. Shifting cultivation in Europe. Shifting cultivation was still being practiced as a viable and stable form of agriculture in many parts of Europe and east into Siberia at the end of the 19th century and in some places well into the 20th century. In the Ruhr in the late 1860s, a forest field rotation system known as Rotbergwirtschaft was using a 16-year cycle of clearing, cropping and fallowing with trees to produce bark for tanneries, wood for charcoal and rye for flour. Swidden farming was practiced in Siberia at least until the 1930s, using specially selected varieties of a Euro Swidden rye a Euro. In Eastern Europe and northern Russia the main Swidden crops were turnips, barley, flax, rye, wheat, oats, radishes and millet. Cropping periods were usually 1 year, but were extended to 2 or 3 years on very favorable soils. Fallow periods were between 20 and 40 years. In Finland in 1949, Steensberg observed the clearing and burning of a 60,000 square meters Swidden 440 kilometers north of Helsinki. Birch and pine trees had been cleared over a period of a year and the logs sold for cash. A fallow of alder was encouraged to improve soil conditions. After the burn, turnip was sown for sale and for cattle feed. Shifting cultivation was disappearing in this part of Finland because of a loss of agricultural labor to the industries of the towns. Steensberg provides eyewitness descriptions of shifting cultivation being practiced in Sweden in the 20th century, and in Estonia, Poland, the Caucasus, Serbia, Bosnia, Hungary, Switzerland, Austria and Germany in the 1930s to the 1950s. That these agricultural practices survived from the Neolithic into the middle of the 20th century amidst the sweeping changes that occurred in Europe over that period, suggests they were adaptive and in themselves, were not massively destructive of the environments in which they were practiced. This raises the question, if shifting cultivation did not lead to the disappearance of European forests, what did? The earliest written accounts of forest destruction in southern Europe begin around 1000 BC in the histories of Homer, Thucydides and Plato, and in Strabo, a Euro unregistered trademark S geography. Forests were exploited for shipbuilding, and urban development, the manufacture of casks, pitch and charcoal, as well as being cleared for agriculture. The intensification of trade and as a result of warfare, increased the demand for ships which were manufactured completely from forest products. Although goat herding is singled out as an important cause of environmental degradation, a more important cause of forest destruction was the practice in some places of granting ownership rights to those who clear felled forests and brought the land into permanent cultivation. Evidence that circumstances other than agriculture were the major causes for forest destruction was the recovery of tree cover in many parts of the Roman Empire from 400 BC to around 500 AD following the collapse of Roman economy and industry. Darby observes that by 400 AD a Euro or land that had once been tilled became derelict and overgrown, a Euro, and quotes Lactantius, who wrote that in many places a Euro or cultivated land became forest a Euro. The other major cause of forest destruction in the Mediterranean environment with its hot dry summers were wildfires that became more common following human interference in the forests. In Central and Northern Europe the use of stone tools and fire in agriculture is well established in the palynological and archaeological record from the Neolithic. Here, just as in Southern Europe, the demands of more intensive agriculture and the invention of the plough, trading, mining and smelting, tanning, building and construction in the growing towns and constant warfare, including the demands of naval shipbuilding, were more important forces behind the destruction of the forests than was shifting cultivation. By the Middle Ages in Europe, large areas of forest were being cleared and converted into arable land in association with the development of feudal tenurial practices. From the 16th to the 18th centuries, the demands of iron smelters for charcoal, increasing industrial developments and the discovery and expansion of colonial empires as well as incessant warfare that increased the demand for shipping to levels never previously reached, all combined to deforest Europe. With the loss of the forest, so shifting cultivation became restricted to the peripheral places of Europe, where permanent agriculture was uneconomic, transport costs constrained logging or terrain prevented the use of draft animals or tractors. It has disappeared from even these refuges since 1945, as agriculture has become increasingly capital-intensive, rural areas have become depopulated and the remnant European forests themselves have been revalued economically and socially. Simple societies, shifting cultivation and environmental change. A growing body of palynological evidence finds that simple human societies brought about extensive changes to their environments before the establishment of any sort of state, feudal or capitalist, and before the development of large-scale mining, smelting or shipbuilding industries. In these societies agriculture was the driving force in the economy and shifting cultivation was the most common type of agriculture practiced. By examining the relationships between social and economic change and agricultural change in these societies, insights can be gained on contemporary social and economic change and global environment change, and the place of shifting cultivation in those relationships. As early as 1930 questions about relationships between the rise and fall of the Mayan civilization of the Yucatan Peninsula and shifting cultivation were raised and continue to be debated today. Archaeological evidence suggests the development of Mayan society and economy began around 250 AD. A mere 700 years later it reached its apogee, by which time the population may have reached 2 million people. There followed a precipitous decline that left the great cities and ceremonial centers vacant and overgrown with jungle vegetation. The causes of this decline are uncertain. But warfare and the exhaustion of agricultural land are commonly cited. More recent work suggests the Maya may have, in suitable places, developed irrigation systems and more intensive agricultural practices. Similar paths appear to have been followed by Polynesian settlers in New Zealand and the Pacific Islands, who within 500 years of their arrival around 1100 AD turned substantial areas from forest into scrub and fern and in the process caused the elimination of numerous species of birds and animals. In the restricted environments of the Pacific Islands, including Fiji and Hawaii, early extensive erosion and change of vegetation is presumed to have been caused by shifting cultivation on slopes. Soils washed from slopes were deposited in valley bottoms as a rich, swampy alluvium. These new environments were then exploited to develop intensive, irrigated fields. The change from shifting cultivation to intensive irrigated fields occurred in association with a rapid growth in population and the development of elaborate and highly stratified chiefdoms. In the larger, temperate latitude, islands of New Zealand the presumed course of events took a different path. There the stimulus for population growth was the hunting of large birds to extinction, during which time forests in drier areas were destroyed by burning, followed the development of intensive agriculture and favorable environments, based mainly on sweet potato and a reliance on the gathering of two main wild plant species in less favorable environments. These changes, as in the smaller islands, were accompanied by population growth, the competition for the occupation of the best environments, complexity in social organization, and endemic warfare. The record of humanly induced changes in environments is longer in New Guinea than in most places. Agricultural activities probably began 5,000 to 9,000 years ago. However, the most spectacular changes, in both societies and environments, are believed to have occurred in the central highlands of the island within the last 1,000 years, in association with the introduction of a crop new to New Guinea, the sweet potato. One of the most striking signals of the relatively recent intensification of agriculture is the sudden increase in sedimentation rates in small lakes. The root question posed by these and the numerous other examples that could be cited of simple societies that have intensified their agricultural systems in association with increases in population and social complexity is not whether or how shifting cultivation was responsible for the extensive changes to landscapes and environments. Rather it is why simple societies of shifting cultivators in the tropical forest of Yucatan, or the highlands of New Guinea, began to grow in numbers and to develop stratified and sometimes complex social hierarchies. At first sight, the greatest stimulus to the intensification of a shifting cultivation system is a growth in population. If no other changes occur within the system, for each extra person to be fed from the system, a small extra amount of land must be cultivated. The total amount of land available is the land being presently cropped and all of the land in fallow. If the area occupied by the system is not expanded into previously unused land, then either the cropping period must be extended or the fallow period shortened. At least two problems exist with the population growth hypothesis. First, population growth in most pre-industrial shifting cultivator societies has been shown to be very low over the long term. Second, no human societies are known where people work only to eat. People engage in social relations with each other and agricultural produce is used in the conduct of these relationships. These relationships are the focus of two attempts to understand the nexus between human societies and their environments, one an explanation of a particular situation and the other a general exploration of the problem. 1. Feedback loops equals. In a study of the duna in the southern highlands of New Guinea, a group in the process of moving from shifting cultivation into permanent field agriculture post-sweet potato, Mojska argued for the development of two OE self-amplifying feedback loops of ecological and social causation. The trigger to the changes was very slow population growth and the slow expansion of agriculture to meet the demands of this growth. This set in motion the first feedback loop, the Ouzvalou loop. As more forest was cleared there was a decline in wild food resources and protein produced from hunting, which was substituted for by an increase in domestic pig raising. An increase in domestic pigs required a further expansion in agriculture. The greater protein available from the larger number of pigs increased human fertility and survival rates and resulted in faster population growth. The outcome of the operation of the two loops, one bringing about ecological change and the other social and economic change, is an expanding and intensifying agricultural system, the conversion of forest to grassland, a population growing at an increasing rate and expanding geographically and a society that is increasing in complexity and stratification. 2. Resources cultural appraisals equals. The second attempt to explain the relationships between simple agricultural societies and their environments is that of Ellen. Ellen does not attempt to separate use values from social production. He argues that almost all of the materials required by humans to live are obtained through social relations of production and that these relations proliferate and are modified in numerous ways. The values that humans attribute to items produced from the environment arise out of cultural arrangements and not from the objects themselves, a restatement of Carl Sauer unregistered trademark dictum that OE resources a cultural appraisal seguro. Humans frequently translate actual objects into culturally conceived forms, an example being the translation by the duna of the pig into an item of compensation and redemption. As a result, two fundamental processes underlie the ecology of human social systems: first, the obtaining of materials from the environment and their alteration and circulation through social relations, and second, giving the material a value which will affect how important it is to obtain it, circulate it or alter it. Environmental pressures are thus mediated through social relations. Transitions in ecological systems and in social systems do not proceed at the same rate. The rate of phylogenetic change is determined mainly by natural selection and partly by human interference and adaptation, such as for example, the domestication of a wild species. Humans however have the ability to learn and to communicate their knowledge to each other and across generations. If most social systems have the tendency to increase in complexity they will, sooner or later, come into conflict with, or into a contradiction with their environments. What happens around the point of a Euro contradiction will determine the extent of the environmental degradation that will occur. Of particular importance is the ability of the society to change, to invent or to innovate technologically and sociologically, in order to overcome the Euro contradiction without incurring continuing environmental degradation, or social disintegration. An economic study of what occurs at the points of conflict with specific reference to shifting cultivation is that of Esther Bozerup. Bozerup argues that low-intensity farming, extensive shifting cultivation for example, has lower labor costs than more intensive farming systems. This assertion remains controversial. She also argues that given a choice, a human group will always choose the technique which is the lowest absolute labor cost rather than the highest yield. But at the point of conflict, yields will have become unsatisfactory. Bozerup argues, contra Malthus, that rather than population always overwhelming resources, that humans will invent a new agricultural technique or adopt an existing innovation that will boost yields and that is adapted to the new environmental conditions created by the degradation which has occurred already, even though they will pay for the increases in higher labor costs. Examples of such changes are the adoption of new higher-yielding crops, the exchanging of a digging stick for a hoe, or a hoe for a plow, or the development of irrigation systems. The controversy over Bozerup a unregistered trademark's proposal is in part over whether intensive systems are more costly in labor terms, and whether humans will bring about change in their agricultural systems before environmental degradation forces them to. Shifting cultivation in the contemporary world and global environmental change. The estimated rate of deforestation in Southeast Asia in 1990 was 34,000 km² per year. In Indonesia alone it was estimated 13,100 km² per year were being lost, 3,680 km² per year from Sumatra and 3,770 km² from Kalimantan, of which 1,440 km² were due to the fires of 1982 to 1983. Since those estimates were made, huge fires have ravaged Indonesian forests during the 1997 to 1998 El Niño +or-0 associated drought. Interdisciplinary project shifting cultivation used to be the backbone of smallholder agriculture throughout the tropics, but today it is abandoned in many places in favor of large-scale cash crop production for example for biofuels. The extent of these changes is not well documented because shifting cultivation land rarely appears on official maps and census data seldom identifies shifting cultivators. Moreover, the consequences of these changes for livelihoods are not well known. The aim of this project is to analyze the extent and consequences of change in shifting cultivation by combining meta-analyses of existing studies and census data with case studies in selected areas. This interdisciplinary project focuses on trends in change in shifting cultivation landscapes and demography, and changes in livelihoods due to these changes. The project will compile data for 8 countries and the outcome is expected to be relevant to planning and policy making on land and forest management. Shifting cultivation was assessed by the FAO to be one of the causes of deforestation while logging was not. The apparent discrimination against shifting cultivators caused a confrontation between FAO and environmental groups, who saw the FAO supporting commercial logging interests against the rights of indigenous people. Other independent studies of the problem note that despite lack of government control over forests and the dominance of a political elite in the logging industry, the causes of deforestation are more complex. The loggers have provided paid employment to former subsistence farmers. One of the outcomes of cash incomes has been rapid population growth among indigenous groups of former shifting cultivators that has placed pressure on their traditional long fallow farming systems. Many farmers have taken advantage of the improved road access to urban areas by planting cash crops, such as rubber or pepper as noted above. Increased cash incomes often are spent on chainsaws, which have enabled larger areas to be cleared for cultivation. Fallow periods have been reduced and cropping periods extended. Serious poverty elsewhere in the country has brought thousands of land-hungry settlers into the cut-over forests along the logging roads. the settlers practice what appears to be shifting cultivation but which is in fact a one-cycle slash and burn followed by continuous cropping, with no intention to long fallow. Clearing of trees and the permanent cultivation of fragile soils in a tropical environment with little attempt to replace lost nutrients may cause rapid degradation of the fragile soils. The loss of forest in Indonesia, Thailand, and the Philippines during the 1990s was preceded by major ecosystem disruptions in Vietnam, Laos and Cambodia in the 1970s and 1980s caused by warfare. Forests were sprayed with defoliants, thousands of rural forest-dwelling people uproots from their homes and moved and roads driven into previously isolated areas. The loss of the tropical forests of Southeast Asia is the particular outcome of the general possible outcomes described by Ellen when small local ecological and social systems become part of larger system. When the previous relatively stable ecological relationships are destabilized, degradation can occur rapidly. Similar descriptions of the loss of forest and destruction of fragile ecosystems could be provided from the Amazon basin, by large-scale state-sponsored colonization forest land or from the Central Africa where what endemic armed conflict is destabilizing rural settlement and farming communities on a massive scale. Comparison with other ecological phenomena, in the tropical developing world, shifting cultivation in its many diverse forms, remains a pervasive practice. Shifting cultivation was one of the very first forms of agriculture practiced by humans and its survival into the modern world suggests that it is a flexible and highly adaptive means of production. However, it is also a grossly misunderstood practice. Many casual observers cannot see past the clearing and burning of standing forest and do not perceive often ecologically stable cycles of cropping and fallowing. Nevertheless, shifting cultivation systems are particularly susceptible to rapid increases in population and to economic and social change in the larger world around them. The blame for the destruction of forest resources is often laid on shifting cultivators. But the forces bringing about the rapid loss of tropical forests at the end of the 20th century are the same forces that led to the destruction of the forests of Europe: urbanization, industrialization, increased affluence, populational growth and geographical expansion and the application of the latest technology to extract ever more resources from the environment in pursuit of wealth and political power by competing groups. However, we must know that those who practice agriculture are at the receiving end of the social stratum. Studies of small, isolated and pre-capitalist groups and their relationships with their environments suggests that the roots of the contemporary problem lie deep in human behavioral patterns. For even in these simple societies, competition and conflict can be identified as the main force driving them into contradiction with their environments. Alternative practice in the pre-Columbian Amazon basin, slash and char, as opposed to slash and burn, may create self-perpetuating soil fertility that supports sedentary agriculture, but that society so sustained may still be overturned, as above. See also, agroecology, crop rotation, Inga alley cropping, MIPA. References. Bibliography Anderson, A Prehistoric Polynesian Impact on the New Zealand Environment, T. Henuahu. Historical Ecology in the Pacific Islands, Prehistoric Environmental and Landscape Change Yale University Press, New Haven and London, 271-283. Bartlett, H. H. Fire, Primitive Agriculture and Grazing in the Tropics. Man's Role in Changing the Face of the Earth. The University of Chicago Press, Chicago and London, 692-720. Becker, B.K. Undoing Myth, The Amazon, an Urbanized Forest. Brazilian Perspectives on Sustainable Development of the Amazon Region, Volume 15 UNESCO, Paris 53-89. Bozerup, as to the conditions of agricultural growth, the economics of agrarian change under population pressure by Esther Bozerup, Virginia Dean Abernethy and Nicholas Coldall, Derby, H.C. The Clearing of the Woodland of Europe. Man's Role in Changing the Face of the Earth, ed. Thomas, W.L. The University of Chicago Press, Chicago and London, 183-216. Dumond, D.E. Swidden Agriculture and the Rise of Maya Civilization. Southwestern Journal of Anthropology, 17301-316. Ellen, Our Environment, Subsistence, and Systems, The Ecology of Small-Scale Social Formations. Cambridge and New York, Cambridge University Press. Golson, J. The Ipomoean Revolution Revisited, Society and a Sweet Potato in the Upper Wachji Valley. Inequality in New Guinea Highland Societies. Cambridge University Press, Cambridge, 109-136. Golson, J. Kike and the History of Agriculture in the New Guinea Highlands. Melanesia, Beyond Diversity. Australian National University, Canberra, 297-307. Humphreys, S. The Intensification of Traditional Agriculture Among Yakate Khmer Farmers, Facing Up to the Dilemma of Livelihood Sustainability. Human Ecology, 21, 1, 82-102. Kurt, P.V. The Evolution of the Polynesian Chiefdoms, Cambridge University Press, Cambridge. Kurt, P.V. and Hunt, T.L. Historical Ecology in the Pacific Islands, Prehistoric Environmental Change and Landscape Change, Yale University Press, New Haven in London. Meggers, B.J. Environmental Limitations on the Development of Culture. American Anthropologist, 56, 5, 801-824. Mojska, N. Production and Inequality, Perspectives from Central New Guinea, A. Strathan Inequality in New Guinea Highland Societies, Cambridge, Cambridge University Press, 50-108. Scott, James C. The Art of Not Being Governed. Yale University Press, New Haven, Steensberg, A. Fire Clearance Husbandry, Traditional Techniques Throughout the World. Herning, Paul Christensen. Thomas, W. L. Man's Role in Changing the Face of the Earth. Man's Role in Changing the Face of the Earth, The University of Chicago Press, Chicago and London. Turner, B. L. Prehistoric Intensive Agriculture in the Mayan Lowlands. Science, 185, 41-46, 118-124. External links, Seeing the Garden in the Jungle, Farmer Power, The Continuing Confrontation Between Subsistence Farmers and Development Bureaucrats by Tony Waters at ethnography.com.